Welcome to tutorial 12, where this time, instead of me going into new material, since there's some leeway in the course right now, what I'm going to do instead is talk about your assignment 3 to make sure that you're understanding the problem and giving you a few hints of how to step through this. Because now you're dealing with solving a problem, but using recursion to do this, and basically finding the cost of the minimum cost path through a whole bunch of numbers that you actually have. And so the key part about this is that your program's got to be reading in an actual input matricey from here, where it'll tell you the number of rows and then the number of columns, and then you have these individual values that come after it. So each line will be one row with all of the rest of the columns and the rest of the columns and the values you have for each, where each of these values here will not be negative and they'll be between 1 to 10, and the fact is you'll have a max of 100 rows and 100 columns. The point of what you're supposed to do is basically you're trying to find the path starting from the 0th column here first to travel to the last column in the end. That is the minimum cost, so that if you sum up all the values along the actual path, it is the smallest sum that you possibly could get from here. And this is where recursion will be very useful, where you're doing this. Now, it's not going to be, say, the most efficient to find the shortest path the fastest. It's just going to find the shortest or least cost path that you can get from one point to the actual next point. Now, there are different levels of what you have for the assignment to actually finish. So your version 1, which would be to compute the minimum cost if you were just starting at index 00 at the actual top, so this top corner that you're working with. First, next one, doing it where you actually have instead of a planar, is doing where it wraps around. So you have where when you're on the edges, instead of it just stopping and doing nothing, it'll actually wrap around. So if we're going up, it would go reverse to the opposite side here and then continue on. And then the final version is where you have to make sure, not just starting index 00, but for all, you have to check what is the shortest from any of these starting paths. So basically, based upon all of these paths, starting points in the very 0th column right here, which row is the best one to actually start with and step through for this. So instead of just jumping into a huge part of the algorithm, I suggest, again, start at one step. Just starting at 00, getting that working. If you get that to work, then it's a slight modification to take it next where it wraps around, then another slight modification deal where it does the best through the first couple of these. Now, when doing this with recursion, the first thing you have to worry about is, okay, what's my base case? So where does it stop recursing going down? And what are my individual steps? Because what's going to happen is we can't just pick the best each time. Say we're at this first column. So I'll just take a smaller example. I'm just going to, over here in OneNote, go say 2, 3, 1, 6. And let's just say we had a smaller. So this one's only got 2 rows. So row 0, row 1. And then 2 columns, column 0, column 1 right here. And we'll assume that we're starting in the actual 0th spot. And so the idea is you're trying to find the minimum path from going across from right here. Now, starting from 2, you have a couple different paths. I'll do this with a different marker. Do it with red. It can go to the 3, or it can go down to the 6. We could also have the 1, which goes up to the 3, or goes over to the actual 6. So you have these different paths that you could get to the actual end. So let's just say we're just only worrying about us at the 00 index for right now, is if we had these two paths, we had to think, well, what's the sum of all the values from here? So this first path right up here, the sum to take that one is the 2 plus the 3, so that is 5. And this other path from the 2 to the 6 is 2 plus 6, which is 8. And so you have two paths, but this one up here in the top would be the better one. So let's do a different color right here. Yeah. This top one would be a better one to actually take because it's shorter from that case. Now, if we expand this a little further, go back to green, add another row, another column, becomes a little bit harder of a situation to figure out. So if we had 2, 5, 3, and I'm just picking random numbers myself here. So 2, 1, 6, 1, 2, 3. So you have these entire paths, and the idea is there's multiple paths. So if we were only starting at index 0, the simpler problem right here, and trying to find the paths through, we have one path right here which goes to the end. So that's our one path through here. We have another path which would go down to the actual 2, and then over and then out. Now we can't go down to 3, is that due to the actual specs it says you're only looking at 3 spots right here. So from base number recursion, one above, one to the next, one here. The idea is the one above here for 2 is out of bounds, so we don't even look at that location. The next one for going great is. So we have, this is the 2 paths so far, but there's more than that. Is that okay? Well, you have different ways we can go. We can go now, go red to make this a little bit easier when I show a different case, is that we have the first 2 paths that are shown in green, but then you could actually have that once we go over here to the 2, we could go down to the 1 and then over, or we could come to this 2 and go down to here, which means like, oh look, we already have like 1, 2, 3, we have then a 4th path right here. We could have the case where, oh, we come down to the 1, then it goes up to the 2, then over to here, or going over to here, and so it's 5, 6. Like we already have 6 different paths we could possibly take from here, and we have to evaluate all of them to see if this is actually possible to reach. Like what is possible? I mean, to get the actual shortest possible costs that we could get. So this is where the recursion will come in nicely, because it allows us to check all these possible paths and then find the actual shortest. Now the idea from here is that we don't want to just pick the shortest as we're actually going, is going to be the hint. Like it may look good for a few situations. So if we look at, okay, look at the possible situations of where we could go. So I'm going to redraw this to make it a little bit lower on the screen, make it a little bit better. So another small example. So 2, let's say 1, 3. Is that we could pick the local optimum of what's the actual best, but it's going to cause some issues in other cases. But we have just to find the short that's going through here. And if we were just starting at this first point, and what we're doing is that's column 0 to start with, then 1, then 2. So we're always moving this way. We're not moving downwards for the path. We're just finding which is the next 3 steps that we can actually go to. So that's the actual columns. So when we're looking, is we only have 3 spots that we can move to, dedicated here. Now this top one right here is to realize that this line we have here is that this one here at the top is out of bounds. So that one we wouldn't have because we want to make sure it's out of bounds. If any of them are out of bounds for this beginning point, we don't go to them. If we're dealing where it wraps around, we'll deal with that next for that actual kind of idea. But that first variant one where it doesn't wrap around, we only have these 2. And the idea is, okay, well, I could look at both of these values, see what they actually are, and then I could pick which is the actual smallest at that time. And so here we got 2, we got 1, so 1 is that. The next is, this would be the next step that we're going to right here. Then we could pick the next smallest if we're looking at the 3. So you have here, to here, to here. So we do actually have these 3 values at this time, and the smallest one out of these 3 would be the 1. And then we can't go anywhere further from right here. We're at the edge of the actual thing, so all 3 of these choices are out of bounds. So we'd be stopping. And we know is this is where we have to stop where we're going first. So this is a path, and it's picking it, but there's an issue that we can't just keep picking what is the closest, the smallest one each step through here. That would possibly lead us to some cases where it's called a local optimum, that it looks good, but you're not going to hit what is the global, the best one for overall. The better idea to actually do, and what we know here, just keeping here, is that we're ending off on right here. So here's a good example of base case, is that when we're moving forwards, we stop recursing when we hit past this column right here. So the maximum column that you're working with. So what would be more interesting instead is to work our way from the backwards, like from here. So from all possible cases for what we could get to is go forwards to them, to whatever we could actually be getting. So right here, so like whatever choices possible, I'm just drawing out like all the possible choices that you could get. And the idea is that when you hit the last one, you stop there and start working your way back for what is the actual optimum. So if we're in this column, so just imagine we're starting in this column here in the very end spot, right here, and we're ending here. The cost at this time for this column is just this value to get to here, because this is your ending point. Whatever, if you had all three of these in this very last column, if we hit here before going out, the most optimal cost in the base case where we're hitting these end is just this value. Then the idea is, well, whatever is the most optimal for the path before this is got to be this value plus the one right here that's from before that was the best. So you want to have it where it recurses and goes all the way down to where it's going to stop for a path, and as it comes back, it builds the shortest path for what it's doing. So as it hits this base column here, for its base case, just returns back that actual value. And then when it comes back to the previous step, wherever you were, so let's say this was the 2, so I'm just going to do a top case, one recursive thing. So let's say it's going through some recursion and it's not done yet. It's going through each of the choices. So it tries to go upwards first. Oh, nope, that's out of bounds, so it doesn't do that. Next, it's going to go to this one here for the actual 2. Okay, we're here. Are we at the base case for the last column? Nope. So it's going to go from here and then recurse off of its 3 choices. Tries to going up again. That's out of bounds, so it doesn't do that one. Comes down to the next one where it's just one column actually over on the same row. Comes to here, so recurses here and realizes, oh, wait, we're at the end, so stop and just return back the cost so far, which is just the 5 that you see here. So I'm even going to redraw this in red. So we've done one path here. We're currently sitting at this one. We've gone here. We're at the 5. It's going to return back, and it's going to send back 5 as that value. Now, this 2 that we're at, it's not done doing its recursive step because it's gone upwards. I realized that wasn't good. It's done here, so now it's got to go one step going down from right here. This has now hit the last column, so it's base case, so this one just returns back 2 as the actual value. Now that we're sitting here at this value right here, this previous 2, looks as it's 3 cases for the values. Is the top one? No, wasn't included. The next one's 5, the bottom one's 2. Hey, that 2 is the smallest out of all of these, so I will pick that one. And I will add that to my value. Now all 3 of these, so now we're going 2, so the one that's right here, plus the minimum of these 3 values. So the top one doesn't count because we went out of bounds. Then we have the 5, then we actually have the 2. So it's okay, so it's going to be 2 plus 2 gets returned back. So 2 plus 2. And so we're getting 4 returned back to here at this time. Now this thing will go back, and this is like a recursion, we're going back to this one. And the idea is, okay, well now that we've returned back to this one with 4, it's already tried going up for right here. Can't do that one. It's got the 4, so now it's got to go down and recurse from right here. This one then starts and goes to its 3 that it can go to. That's done. So that one. Hey, look, that top one's a base case, so it'll just return back 5. Goes to the 2. Hey, look, 2 is another base case, so returns a 2. Then here goes back, and hey, here's a 1, so this returns back 1. So now we've got these 3 values right here, the 5, the 2, and the 1. I'm going to pick the minimum out of that, so it's going to be the 1 plus this 1. So 1 plus 1 right here, and so then 2 gets returned back right here. I accidentally erased that 2. So when we come back to here is now for this evaluation of that 2, we look back to, okay, well, where was it? From right here. So that's got the top is 4 is not here. We've got this 4 right here. We've got the 2. So 2 is the actual minimum from right here. So it'll be 2 plus 2. which gives you 4. And the way that we got that was actually going, look at me erasing everything from right here, is that it was going down to this one right here, down to the actual one, and then out. And that's why we got from here the 1 plus the 2, which then gave us 4. So these two, so 1, 2, 4. And this would be our shortest path through this one, but starting at 2. That doesn't mean it's the shortest from everything from right here, but you've gotten this path. So the idea is, I hope that you could see where I was going through it. So even if I go through this once more, it's more the base cases as you're actually going through it. I'll just go back to green. Get all this looking properly. So what we know so far is our base cases is this, the column that we have here. And so again, in this case, we have 3 columns from right here, 0, 1, 2. And so this will always be the number of columns you have minus 1. We know that's right here. This is our base case where we stop doing a recursive because it hits the end. There's nowhere else it's going to be able to move. And we would just be returning back the value that's coming through there. But when we're going through each step, we're still evaluating, okay, first one, going up, it's out of bounds. Going to the next one, it isn't. Tries looking up right here. And the idea is that each time I'm stepping over for this, when you're checking each value, is that, hey, this one's in bounds, we do a thing. This one is in bounds. So this right here is a recursive call, this step here. So this is one function call, and then this is where I'm making a recursive call from right here. And we need to know our recursive steps. But what you're seeing the difference here is that, we're in column 0 here. Next is a change of what column we're in. So our next recursive call, the parameters is changing what column we're in, but also what row we're going to be in. So in this case, it went up by 1 column, but we have a different case here is that if we're going up here, we're going back 1 row, or the same row, or adding 1 to our actual row. So each step going through here is going to be a recursive call. So example here is we try to check, hey, the first one's not in bounds, so we don't do a recursive call. This one is in bounds, so we do a recursive call. We're giving it a row of 0, but a column of 1. So we start at 0, and we're adding 1 to it. Right here, we're not the base case because we're not hitting this last column, so this function here will start going through the same steps of recursing again. Okay, this one's out of bounds. This one isn't, so it makes a recursive call to go here. This one here then is a base case, so it just returns coming back as you're doing this. Now the idea here is this is where you can also start building your actual list. And it's mentioned in the assignment, there's a little bit of wasting where you're going to be creating and deleting as you're going. But when you hit the base case, the starting thing for the path here is that you would start adding to the list at this time. And what I'm going to give you the hints is you're going to be doing an insert to the front. The idea is you're always adding it to the actual front. So anything you have new. So here in the actual first case, for right here, is that we just have it as 5. We would just be adding a list to this as being 5. So if we had our head, it's null. We hit the base case of it actually being 5, and that's going to be returned. So this head instead will have the data being the values of where we are in it. And this is a key thing is now we're keeping the row and column values. So the row is 0, the column here. So if I go here, this is at 0 and then 2, where it's always row and then column. Right here, this is what we have so far in the actual list. Now when it comes back from this is where the other linked list, well, you'll have multiple linked lists and you have to merge them together or pick the right one to work with. So we come back to the top one is 5 is going to be returned. We're back at the 2, so coming back from a recursive call. And a hint here is you're going to have some returns, you're going to have some reference variables for this too. This one will then look down here for the actual 2 value. Oh, this one's within bounds, so we'll go to recurse from right here. It'll return back, saying again we're giving you 2 as the return value, but then it'll give you a list that has now value of row 1, column 2 within it. And now we have these two lists from one call to the actual second call that are also being returned back up to this one up here. So now it's gone through its 3 steps that it's needed to. So this top one to this one. So 1, 2, 3. So you're going to realize you're going to have 3 recursive calls in one function that you're doing. So for each of these steps, it gets between 3. It knows the first one is thrown out because it's out of bounds. It then has the 5 and the 2. So this is the one that resulted from the 5. So down here, if you see at the bottom where I'm drawing, and then the actual 2. You have the 2 lists. And so then from here it decides, okay, the 2 is the actual smallest, so it will throw out the list, which means you need to delete it properly because you have allocated. So you need to delete that list and only keep the list that you got where it was 2. So you had this head here, and now it's going to add everything together, so you're getting the cost of 4, and then rebuilding that list, so it's going to do an insert to the actual front from right here, where you are, in this case, in column 0, so right here. So row 0, column 1, so 0, 1, and have this list. And now this entire list here is going to be given back from this. And I'm going to give you the hint, you're going to probably want to pass in the reference to the head as an actual reference variable. So this can be updated as you're actually going. So this will keep happening because now this entire list is given up here to the actual 2 from right here. But now that 2 has got to go up. Okay, well, all these other calls are done. Right here, so this 2 here has done this one, done the one to the top, which gets thrown out, so it needs to go off and build this list from here of what is the actual shortest that it will go through. And the idea is that it's going to build between these. It's going to look at all 3 of these and build the list and pick which one is the actual best. So you have these returning back 3 lists and building up. So I hope this gives you a nice idea of how to start doing this, say in the very beginning. So it is these recursive. You will have 3 recursive calls you got to do. You're going to have the base case, which is having this column, which you'll just be returning back the value as the cost, and you'll just be inserting this one value as the beginning of this list. When you come back from a recursive call, it looks at the 3 spots it has, and for all the ones that were within bounds from right here, that were valid here, then it picks which one was the minimum cost, and then it deletes the 2 other lists and only keeps the one list that it had so far as the minimum cost and adds this value to the overall cost and to that list, so its location, and then returns back up and continuously keeps doing this entire process. And what's even fancy about this is even though we wrote something that's only started at 0, 0, well, the idea is you just do that. You just run your same algorithm for 0, then the next column and the next column, and you just keep checking for which one is the minimum out of these 3 that you get. So the same algorithm you run here, you run it once, get back its entire path and minimum, and you just do it for all of the columns in here, basically a loop afterwards. So you could write one algorithm that's going to be recursive and do it for the rest, then one that's just going to call that recursive algorithm, so just given the entire matrix and does it for each of the starting points in column 0 and finds out which one gives back the minimum cost and only keeps that path and deletes all of the actual other paths that you're actually working with. Now, the other thing that you needed to do is you need to worry about how do I get this to wrap around? And that's actually a lot easier than you think, and even these levels, is if we first just think about, well, how can I start getting the next values in the columns? And how does that work with any of them? And so let's just say, just imagining here that I'm just going to go again with a smaller, let's say, 2, 3, 4. So let's imagine we're just right here. So this is row 0, row 1, row 2, column 0, column 1. And the idea is that from 3, I can go up to these other values. And what you have to know is first, this 3 that's right here, it is at row 1, column 0. Now these ones right here, so all 3 of these that come after that are always going to be at column 1 because they're one step that's actually in front of it. Whereas you look at the difference, so like this one here is going to be at column 1, column 1, column 1. But they're each at 3 different rows. So we know this first one right here is at row 0, the next one is at row 1, and the one after that is at row 2. And what's nice is we just have to start looking, well, this first one's at row 1 right here, and if we're going to the one that's above it, it's supposed to map to row 0 for that. So I'm just going to do it between these actual values. So working at a value from right here is if we're at our current value, this is at row 1, it's supposed to be mapping up to the top one is supposed to be at row 0. The one in the middle is supposed to be at row 1. And the one down here is supposed to be at row 2. And what it is going up here is this is just -1 from the current row. This is just 0, so no change to your current row. And this is just +1 from the actual row. So it starts giving a formula. And what we know, all of these are always at column 1, like one column. So they're always just +1 to your column for all three of these. So what we can work out is for an actual formula to get each of those. So first off, just getting the actual row and column values from right here. And so what you have first is if you have your column here is C, and your row you're working with is that your new column is always equal to C plus 1. You always know that. Now your rows from right here is because you have 3 different values. So it's still the same column, but I have 3 different values I need to actually get to. So I have the 1 that's above, 2 that's the same, 3 that's next. So I'll even draw this out. So this is R going up here, going here, going here. And you have the same as these 3 values. So we know that this is going to be the column, that new column from right here. But to get to right here, it's equal to your, I'm going to call this upper row. So the one that's above here is equal to your row -1. So that's getting that one right here. Your next row, which is on the same one, call this NR, is equal to your R right here. So no change right here. That's for this middle one that's right here. And the one that's below, so BR, I think of this one as being the one that's below, so the one right here, is just equal to R -1. And so that gives you 3 then actual values. So just formulas of where to get to them. So you know I'm going to have to check these 3 spots. I need the upper R plus your new column. I need my next R, which is on the same row at the new column. And I need the actual row that's below it, your new column. And these are the 3 ones when you're starting at your row and your column from right here. And these are your 3 new values and just getting that formula. So again, NC is always just equal to your column +1. Your upper R is equal to R -1. Your next R is equal to R, just equal to R with no changes because you're still in the same row, you're just going up 1 more column. And then for the value that's below it, for the actual 3, so that's the below one, is just your R, +1, sorry, +1. Screwed that up in my formula. So make sure the one, R -1, then R +1. So again, I'll go back to where we have an example. If I was to do this. So let's say we're at, let's say even here, I'll just do where we're starting at 0, 0 is your starting point. And I need to get the row values for those 3 different ones from right here. For the new column, it's just your column +1. So it'd be at 1, then 1, then 1. Then you have your upper here, which is your row -1. So we have that as 0, because this is our column, this is our row. So that'll be -1 from right here. Then we have just our normal row, so 0. And then the below one is your row +1. So this would be at 1. And this gives you your 3 indexes that you need to check to and basically recurse on. But what's nice here is, first off, if you're just getting it to stop to not wrap around and we're dealing with out of bounds, you can just check this. You know, negative values are out of bounds for the actual array. So this row is out of bounds from right here. We can also check the base cases of what is our columns that are coming in. Does it equal to your actual, like, one less than your max column? And we don't need to stop from right here. So you're out of bounds. So that's the thing. If you're dealing with the out of bounds cases, you just have to know, okay, well, you know, it's my row has to be greater than or equal to 0. And your row has to be less than the number of actual rows you have in the actual list here. So the NR here is your actual total number of rows, so less than. So not less than or equal to, just less than. You know, it has to be in bounds from there to actually check. But the next thing is when you're getting these three values and you're worrying about, hey, this circular case from right here, is you can just check. There's just two cases you have from right here. Is if you're going off. Say it says right here where it's -1. When it's -1, it's supposed to go to right here, go wrapping around. That we're supposed to wrap around from right here. So what you can just check is something that maps is that you can do this formula right here first just to get all of these values. And then you can just do something to actually check, okay, hey, have these gone out of bounds? If they're out of bounds, I've got to wrap them around. So like in this case, when we've got -1, what you know is 0 is the smallest row you could have. So if you have if it's less than actual 0 from right here, you can actually take, oh, the only case we'd have right here when we're stepping is would be -1. And so then you would say, okay, well, I want to change that. It should be the number of rows. So the number of rows plus right here, just -1. So if you find it here that if this is -1 from right here, because we're only taking one step when we're looking at this from right here, then it has to be, oh, if I want to wrap this around, it should actually be calculating out then NR -1. So we calculate this value. If we find out that this upper, so the upper R that we're working with right here, if we find that that one is then -1 from right now, then you're like, okay, good, we're easy enough. Change that around then just to be your N minus R. So your number of rows -1. Right here. The other case then is if you're at the actual bottom and going downwards, which would be this one. So the cases right here is these middle ones where you're just going next will not go out of bounds. It's only these ones where you're going the upper rows or going down the rows will go out of bounds. And so the top one from right here, it'll be like, you're always minusing 1 from it. So that's the case where you could go to being a negative value. And if it goes from a negative value, it's supposed to wrap around from right here. So really, we can just take it, whatever that value, calculate it, minus it from the number of rows. Or if we know that we're only taking the one step like we're doing here, you can just say, okay, if this is -1 after that calculation, then change it to be the number of rows -1. Whereas the opposite from right here is that if this value goes larger than the actual array itself at the actual bottom, then so here's the number of rows. So if the value you calculate here for the below R, so if if your BR is greater than or equal to the number of rows, then you just set BR equal to 0. Should be going back and wrapping around. So really it's just once you calculate these values, you see, okay, how do I get them then to check, are they out of bounds? If they're out of bounds, then wrap them around to the proper location you should actually get. So if we took, say, a smaller example from right here, so let's say 2, 1, 3, 5. So what we have here is the number of columns here equals 2, and the number of rows equals 2 right here. And we're just going to start at 0, 0, so 0, 0, and getting its 3 values. So the one going above, the one going here, and then the one going here. So that means we have your upper R, your normal R, and your below R. So we calculate each one of those, which is then again your R -1, just your R, and your R +1. and here we have 0, comma 0. That's our R, that's our column. And so our R minus 1 gives you, that's 0 minus 1, which gives you minus 1. Then your R is 0, which gives you 0, and our R plus 1 1. Now we know we check through the conditions, so we've calculated these from here. We've just gotten 0. We've gotten minus 1. We've gotten 0. And here we've gotten 1. This one is below 0 from right here, so we set it to your nr minus 1. So that's nr minus 1. Which equals 2 minus 1, which equals 1. So I would change that to be 1 right there. So in this case, kind of weird, it wraps around. Basically to being that 5 right there when we wrap around for this smaller matrix. That's all that I was doing for right here. So now we have those values, and we can build them completely up by being 1, and it's at column 1, because we're always going, your new column is your column plus 1. Then you've got 0 and 1, and we've got 1 and 1. So weird in this case, but that's the wrapping around. Versus if we were doing it at the bottom, right here. So now we're going to go saying we're starting with this one here instead. That's at row column. So row 1, column 0. Your upper row equals row minus 1, which equals 1 minus 1, which equals 0. Giving you that one. Your next equals just your row, which equals 1, which is this one. And then this one last here, your below R equals your R plus 1, which equals, in this case, 1 plus 1 equals 2. But in this case, 2 now is greater than the number that we have right here. So we recalculate that to actually be 0. So you get that 0. So then it wraps around that the third one actually ends up being this one up right here. So we get 0, comma 0, 1, comma 1. So first one here, sorry. The 0, comma 1, then 1, comma 1, and then 0, comma 1 for those 3 values. And that's just the wrapping around. Okay, well that's been 30 minutes of me talking about this, but I hope that gave you an idea first for the recursive steps and understanding your base cases and what you have to do to step through, ideas of how you're building a linked list once you're going from the base case backwards, building a linked list and deleting the ones you don't actually need. And then also a general formula for actually then picking out how do I get those 3 values of the upper, the next, and the below, and then how do you start checking and dealing with the actual wrapping around from there. Other than that, I hope you guys are doing as good as you can this time as school just keeps going on by faster and faster. If nothing else, make sure to check in on yourself first and make sure that you're doing okay. If you haven't done it in a while, maybe reach out to a fellow classmate you know of and check in and see how they're doing, or into another friend or someone you haven't talked to in a while and just check in and see how they're doing. Because I always know I personally appreciate even when I get random out of the blue check-ins from people, especially this time of year. Other than that, keep being the awesome people I know you are, and if you don't think you're awesome, you're wrong, I'm right, you are awesome.